At the previous session, we have talked about how to make some modifications to bundle layout for shell and tube heat exchanger, either by decreasing or increasing tube length or tube count, number of tubes for shell and tube heat exchanger to make some little changes for your tube layout bundle. But in this case, for the air fan, it's a bit different and involves some specific techniques since the TL or tube layout editor is disabled at this case. If you haven't watched the previous session, I highly recommend you to watch for that tutorial content as well. So, hello and welcome to the Convert channel. For it, I have complete this air fan for the first tube raw and for the third and the fourth tube raw. As you can see, we have the identical tube pitches, and for the third and the fourth tube raw, we have condensation that is going to happen through the tube. That is not recommended to use the same pitch, since the velocity of the process fluid is going to decrease as it passes through this actually return tube passes. So have to make some changes at the air fan tube bundle layout. So the 3-bar menu on the left side of the HDRI software, as you can see, we have tube type that we can insert another tube type just at the table. Once you click on the add, as you can see, we have a new tube type for this air fan, and at this drop down menu you can switch it from plain to the high fin, since we are going to use a fin at the outer, actually at the outside of this tube, since we have air fan that we need to insert or embed some fin at the outside of these tubes. As you can see, the 3-bar menu just right here, to new added tube type inserted just right here, but it's time consuming to input all this data or whatever it needs for geometry of the high fin or tube geometry. It's a kind of time consuming. We need to actually perform drag and drop, and we would be able to copy all the data effortlessly without actually consuming any time. So as you can see at the tube bundle, for example, I'm going to click on the sub tube raw, which is a return tube pass. You can see the new added tube type was inserted right here at the drop down menu. So but I'm going to increase the tube pitch of these two third and the fourth tube raw, since the condensation is going to happen so as to in order to avoid operating in a gravity flow regime. I highly recommend you once again to watch for and look for the gravity and shear flow regime tutorial content that we have discussed on the previous session. If you haven't watched that yet, just look for that as well. So, for the new added tube raw, I need to just adjust the transfer pitch, since I have copied this value from the first tube raw to the 3-bar menu just right here. We need to make some little changes. For example, just take this as an example, 120 millimeter as the distance between to adjust a tube. Actually, tutorial value do not make any industrial specific or whatever it means. Just at the tube bundle layout, you can then click on the third tube raw and switch this drop down menu from the first into the new added tube raw. Then click on apply. As you can see, we have different tube pitch at the third raw in comparison to the first two tube raw. Do the same for the fourth tube raw as well, and just again click on apply, then okay. This actually a specific technique at the air fan is highly recommended where we have condensation, Since we have condensation, our gas is going to turn into liquid. The liquid typically have less velocity and less flow rate within each tube. We need to decrease this, actually increase this tube pitch to make sure we have less number of tube at the return passes where the condensation is going to happen, and consequently to make sure that our process fluid is going to operating in a shear flow regime to avoid hammering from happening at the inside of each tube. Once you have completed your simulation, you can easily click on the run case, and the tube side monitor on the left side of HDRI, actually the 3-bar menu right here. You can search for the shear. What you can determine with actually your process fluid is within a shear or the gravity flow regime. We have different pages at the bottom of this page. You can search for it and look for if your simulation or process fluid is within a gravity or shear process or shear operating flow regime. Once again, I highly recommend you to watch for the shear and gravity differences of the previous session that we have talked about it, to make sure that you have learned the concept behind and the differences between these two flow regimes. So, I hope you the best of luck in the next step of your career. If you have any question, just let me know in the description below. Have a good time. Bye bye.